All right, everybody. We are moving on to 7.3, so triangle similarity. This is going to be similar to the times that we prove triangles congruent with things like side, 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 angle, side, angle, side, angle, side. For triangle similarity, if you want to prove that two triangles are similar. So let's remember what similar means again. Similar means that all angles are congruent and then all sides are proportional. So it's not the same as congruent, so we're not going to have all of the same ways to prove that these are similar that we did for congruence. But we have some of them that are the same. For example, the first one that we're going to go over is angle, angle. So while this was not a way you could prove triangles congruent, it is a way that you can prove triangles similar. So if I have one congruent angle in a triangle, and then I happen to have another one, I can say that these two triangles are similar to each other. So if I label these with some letters, first of all, I would know that they're similar because I could say that angle B and angle F are congruent by the third angle theorem. So once I know that all three angles are the same in any two triangles, they have to be similar to each other. They're definitely going to be proportional. There is a way to go prove this, and I could show it to you, but if you want, let me know. But if not, we can just go through it this way. So I can say that triangle ABC is similar. So we use the tilde to show that something's similar. So that's congruent, that's similar to triangle EFD by angle-angle similarity. So I could write a proof out for this. I might have one example later that I'm going to show you that you can do this with proofs. It's not going to be that extensive. We're going to spend most of our time applying this to either an application example or to just doing it with a couple triangles. So angle, angle, let's just write like a little description. So angle, angle similarity is if you have two angles that are congruent to each other. In two triangles, the triangles are similar. So, that would be true. So the other two are going to be similar. We have one for side, angle, side, and one for side, side, side. So I'm going to scroll down a little bit so I can move this up so that we're all on the same screen here. So I'll do, what do I have first up here? I have side, angle, side first. So let's do that first. So if you have, it works the same way as side, angle, side in congruence that it does in similarity. The only difference is the sides are not congruent. They're just going to be proportional to each other. So let's give an example. If I have this side as 8 and this side is 4, say I had this side was 6 and this side was 3, and I knew that these angles were congruent to each other. That's an example of triangles that are congruent, that are similar by side, angle, side. So I could label these and I could write a similarity statement that shows that these are congruent to that shows that these are similar to each other. So I would be able to say that triangle GHI is similar to triangle JLK by side, angle, side similarity. We usually put the tilde at the end right here to show that it's definitely similarity. So if you're wondering why I'm putting that, it's to differentiate it from the side, angle, side that we know for congruence. So that's why I'm putting it there. So let's write that out. So that the statement that you'd want is if two sides are proportional in two triangles and their included angle is congruent, the triangles are similar. So that's the if-then statement that you can write out that would show why that's true. Now I realize that I didn't show that the sides are proportional, but if I showed that JL and GH were the same as LK and HI, I would be able to show that 8 over 4 equals 6 over 3, which both equal 2 over 1. So that's why that's congruent. If you had shown it the other way, where GH over JL and you'd gotten 1/2, that's okay. So if you're just showing things that are proportional to each other, that's a perfectly fine way to show it. So you got that. The last one is side, 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 which is pretty self-explanatory at this point. So if you have three sides that are proportional to each other, then you know that the two triangles have to be similar. So let's just give a quick example. If this is a 3, 4, 5 triangle, and this is a 6, 8, 10 triangle, we'll throw some letters on here. All right, so I could show that these two triangles are similar to each other by just writing out a similarity statement or writing out a statement of the proportions. So I could say that PQ over MN should equal NO, sorry, I'm doing that wrong, RQ over NO, which should equal PR over MO. So plugging in some numbers and just showing that that's true, you have 3 over 6 should be equal to 8 over 10, 4 over 8, which should be equal to 5 over 10. Those all equal 1/2, so you've shown that they are proportional to each other. So you can say triangle MNO is similar to triangle, what do we got, MNO, so this should be PQR by side, side, side for similarity. If you want, we can write out the statement for that and show, and the if-then, so that way you have that for your notes. You could say that if two triangles have three sides that are all proportional, they're similar. One other vocab word that's going to come up at some point, I don't know exactly where, but I'll have to show you guys. This number right here, or this number right here, is also called a scale factor. So it's got a few different names depending on what context you're using it in, but that is usually given as a scale factor. Basically, you're showing it's a scale between two different polygons or two different sets of shapes. So that's just one word that may come up eventually. So those are the three new things. All I'm going to do in the next few slides is apply them. So that first, oops, wrong one. That first 8 minutes is all the new stuff. Everything else is just going to be some examples. So if I were you, I would try them out first. So I've got these 4 examples here. Try them out and just check your answers at the end. If you want to see them all the way out, I can show you right now. For this first example up on the top left, if you got the last angle right here, angle A, if I did 52 and 81, I get, what is that, 133, which means the remainder would be 47. So this angle is 47 degrees. And at this point, I can already say that they're congruent by angle, angle. I've got that that they're similar by angle, angle. These two I have congruent, and then these two I have congruent. So these are similar by angle, angle. So it says to write a similarity statement, so I should say, let's move that down a little bit. Triangle ACB is similar to triangle FHG. And those are similar by angle, angle. All right, if I show the next one, I already have a set of congruent angles here from the lower left. I've got a right angle right here, and if these two angles together are in a linear pair, this should also be a right angle because they add up to 180, and then if they add up to 180 degrees and one of them's already 90, the other one has to be 90. We've proven that before. So already I can get that triangle PSR is similar to triangle, what would that be, TSQ. by angle similarity. If I look at the other two examples that are over here, I've got some sides that should be proportional to each other. Let's check them out. So I'll label and show kind of which sides would be proportional. This side that's 6 is the longest side in that triangle. The longest side in the other triangle is PS, so I'm going to compare those two sides. And then I've got the two medium sides in the larger triangle. So I've got this blue one and this blue one, which should be proportional to the same in the other triangle, which would be this one and this one. It's a little hard to see, but if you drew them separately, you'd have one that was 4, 4, and 6, and you'd have another one that was 6, 6, and 9. If you compare those, 9 over 6, should that be equal to 6 over 4, which should be equal to 6 over 4? Those all equal 3 over 2. So I can say that, yes, those are proportional by side, side, side. So I would say triangle PQR is similar to triangle SRP. What is that? Yeah. SRP by side, side, side similarity. All right, I've got my last example down here on the lower right. So immediately you've done enough proofs, you can just start drawing in vertical angles. And this is probably going to be a side angle side one. Let's check. So if I compare 20 to 15 and then 16 to 12, both of those fractions reduce to divided by 4. So that's 4 over 3. So that would be like my scale factor. So since the sides are proportional and I've got this vertical angle, I know that those triangles are going to be similar by side, 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 or side angle side. So I can say triangle TUX is similar to triangle VXW by side angle side. So that's some examples of that. Just showing that you can recognize that two things are similar to each other. That's all that we're doing here. So that's that. I got two more examples for you. One of them is a proof, and then one of them is an application. So the proof is here, it's pretty quick, and the application's here, that's also pretty quick. And then we'll go from there. So I'm given that these two lines are parallel. So anytime you're given parallel lines, you should automatically try and find some angles that are going to be congruent to each other. So right off the bat, I can say that I've got some corresponding angles here and some corresponding angles here. And I've already done it. Now I've got two triangles that have two angles so that they should be similar by angle, angle. So if I wanted to show you what a pretty short proof would look like here, I mean, some of them could get longer, but this is just a simple example. I could state my given that MN is parallel to KL. That's given. The second thing here could be that angle JMN is congruent to angle JKL. And also that angle JNM is congruent to angle JLK. That's because corresponding angles are congruent if and only if the lines are parallel. You know that from chapter 3. So those are my given information, and that's what I got from my given information. The last step right here, which is the very last one that we just learned, I could say that triangle JMN is similar to triangle JKL, and that's from angle similarity. So yeah, it's pretty short. It's not too bad. There are some that are a little bit tougher because you have to prove that sides are proportional instead of proving that they're congruent. So there are some numbers that go on in the proofs, but again, we're not going to do a whole lot with that. We're going to spend more time doing some applications of this stuff. So that's that example. I'll go to the last slide. This is actually an example I gave on the chapter test the last couple of years. So I'm obviously not going to do it now, but so it's an example of something that I think is important that, that you could apply. So you've got a figure here, and it says in order to measure the distance AB across this crater, the surveyor locates points at A, B, C, and D as shown. This actually is a way that you can calculate distances. It says what's AB to the nearest meter and the nearest kilometer. So I need to find AB, which is this one on the far right. So that's what I need to find. So I've got two similar triangles. So I should be able to set up some sort of proportion to show what AB is. So I've got, maybe I'll use the small side on this triangle and then the large side here. And then I should be able to compare that to the small side on this triangle and then the larger side right there. So I should be able to say that 644 meters over the total, which is 1,444. Doing that in my head, but that should be right. That should be equal to CD, which is 533 meters, over AB, which is what I want to know. Again, I've got this the small side over the large side. I've got the small, I don't know what you could call it, just another small side, I guess, over another large side. So that's how I'm showing that this is true. Let's just calculate that. So I can cross multiply AB times 644 equals 1,444 times 533. If I divide, AB is whatever this is in meters. So let's check that out. It should be 1444 times 533 divided by 644. Looks like 1,195. I'm just going to round to the nearest meter. So that's 1,195 meters. If I want to get that in kilometers, I can just take the decimal place and move it 3 times. So that's 1.195 kilometer. So to the nearest kilometer, it's roughly 1 kilometer. So either 1,195 meters or 1 kilometer. The only other thing to note about this question is, yes, you could have used the other side. So you could have used this and the whole side. Your numbers are going to come out slightly differently. I realize that these triangles aren't exact as far as their proportions go. They're very, very close. So in a real example like this, the triangles may be so close to each other that you can use them for a reasonable estimate. So it's just asking you to round it anyway to the nearest kilometer. So there is some error there. So if you calculated it and you got like 1,200 or a slightly different answer, that's fine. But anyways, that's it.